Hello guys. Today we're going to continue talking about the GCF or the greatest common factor, but this time we're going to be talking about multivariate monomials, meaning there's going to be more than one variable in each of our monomials. Today, in this first example, we're going to be comparing 12x to the fifth, v to the eighth, and 30x to the second, w to the fourth, v to the third. I know this looks like a lot. I know that. But it's actually really quick and really simple. The only real anything that we have to do is let's create those factor trees for 12 and 30, those coefficients. Because I don't know what the greatest common factor is between 12 and 30 off the top of my head, so let's just figure it out. Let's do that factor tree of 12 first, which we know starts out with 6 and 2, and then 6 goes to 2 and 3. Okay, let's do the same for 30. We know that 10 and 3 goes into 30 and 5 and 2. Okay, so we have successfully factor treed our coefficients. I see that in my factor tree, both trees have a 2 and both trees have a 3. Therefore, our GCF, we multiply those together, it's going to include a 6. Now, when we're looking at our variety of variables going on, thinking back to the second quick trick that we talked about in the last video, we are going to take the lower of the powers between those matching variables, and that is our greatest factor for that variable. So on our left-hand side, we have an x to the fifth, and on our right-hand side, we have an x to the second. Let's take our lower of the powers, which in this case is 2, and that joins our GCF. Now let's look at our next variable. Now on our right-hand side, there's a w, but there's no w's over in our left-hand side, so that's not even included in our GCF. We don't have to worry about the w variable at all, but both terms do have our v's. In this case, there's a 3, and in this case, there is an 8. So let's go ahead and take the lower of the variables, or the lower of the exponents, v to the third. Therefore, our GCF of these two terms is 6x to the second, v to the third. Let's go ahead and do it one more time. This time, let's find the GCF of 8, y to the third, x to the fifth, and 28, v to the eighth, y to the eighth, x to the fourth. As always, let's go ahead and take those factor trees of our coefficients, starting with just 8. We know is 4 and 2. One step further, 2 and 2. Next up, let's do our 28, which we know is 4 and 7. 7 is a prime number. We cannot factor that any further, but we can factor 4 to 2 and 2. Now, looking at our trees, those lowest hanging leaves of our trees, we see that both have 2 2's. So we know that our GCF is going to include a 4. 2 times 2 is equal to 4. Then let's talk about our variables. First up, on the left-hand side, we have y's, and good thing, our right-hand side also has some y's. We take the lower of the exponents and add that in to our GCF. Now, going back to our right-hand side, there's no v's over in our left term. There's no v's, so we cannot kind of pull that out or factor out any v's from the right-hand side. So it's going to remain there. Now, looking at our x's, this time the lower exponent is a 4, so we're going to add in x to the fourth in our greatest common factor. We can pull out or factor out 4x's from both terms. Therefore, our GCF of the two terms that we're looking at, 4y to the third, x to the fourth. Great job, guys. See you tomorrow.